Yeah, thanks, Martel, for the kind introduction and also for inviting me, the whole NEST community, to this webinar series. It's really nice to join this group of people, and I hope we have some good discussion in the next 1 hour or 90 minutes, I guess. Before we start, I would like to acknowledge the traditional owner of the land from which I'm joining this webinar today. I'm currently based in Canberra, and the traditional owner of this region in Canberra are Ngunnawal and Ngambri people. I pay my respect to their elders, past and present. As I was introduced, my work in recent year has focused mostly on system thinking and systems modeling for understanding sustainability transition. And I hope that this could be also something useful for the NEST community. What I plan for today is I would like to start off by some general background information about transitions and systems modeling in general. And then I'll give you an overview of 2 specific studies to demonstrate how system thinking and system modeling can be useful for transition research. Among different definitions that exist in the literature for transition, I find this particular definition more intuitive. Transition as pervasive change for persistent problems. Persistent problems are usually the negative side effect of the system, which we rely on to meet our needs, the symptoms of an unsustainable society. And the pervasive change is basically a fundamental shift across domain to overcome these problems. With this definition, one can see that transitions can be either purposefully pursued or can be emergent, to be navigated. And with both definitions, one of the powerful ways to influence the behavior of transition is through goals and purposes. Goals and purposes can act as direction setter for transition. They can also help us identify where we are lagging behind and therefore guide actions to cover the gap. One of the important set of goals that are currently shaping our transitions to a sustainable future are framed by the United Nations Sustainable Development Goals, or the SDGs. For those of us probably who might not be familiar with the SDGs represent a balanced future with social inclusion, economic prosperity, and environmental goals in 17 different goals and 169 specific targets. With a SDG lens, we can think of many transitions that are in making or transitions that have happened in the past. To give you a few examples, economic reform in the past 4 decades in China has pushed more than 90% of population out of extreme poverty. And with this increase in affluence, there have been obviously lots of other positive and negative changes across scales and domains. Internet access in sub-Saharan Africa and South Asia has expanded rapidly in the last 2 decades. And with that, many things have changed, the way that people live, their businesses, banking, agriculture, and so on. And even in less than a decade, Norway has experienced one of the fastest transitions to electric vehicle, paving the way for broader decarbonizations in the transportation sector. While these pervasive changes are happening in different sectors related to the different SDGs, they still share certain transition characteristics. For example, the response of all this system in transition to internal and external drivers are usually nonlinear. And that's one reason that we usually see a mix of uptake, acceleration, and stabilization over the life cycle of transition. All these changes happen in a context subject to uncertainty, subject to future contingency, and these uncertainty and contingencies impact the way the transition emerge in the future, impact the patterns that we see in transitions. And last but not least, all these changes are also embedded in a multi-sector context with lots of interactions, synergies, and trade-offs with other systems in the environment. I think all these together are saying one thing, that transitions are complex and uncertain. And for this reason of complexity and uncertainty, we have difficulty in understanding them and also limited ability in managing them effectively. And again, for the same reason of complexity and uncertainty, we use systems modeling or system thinking in general. Systems modeling can help better understand causal relationships and also feedback interaction that we have between and within systems. For example, how the goals that we set can shape the way that transition emerge, how transitions that we have would create synergies and trade-offs, interactions, different side effects for the rest of the system in the environment, and how the systems and the surrounding environment feedback and influence the way that transitions are emerging. Systems modeling, and in particular systems dynamic modeling, which is a specific approach within the system science, was primarily advanced by Jay Forster at MIT in developing the world model to study the interaction between population, economy, and ecology, a model which also later underpinned the seminal work of the limit to growth in 1972. Since that time, the co-evolution between systems modeling and sustainability science has continued in multiple frontiers. For example, in the specific interface of modeling and transition research, which I suppose we are all interested in, with some of our colleagues in the STRN community, including Jonathan, who joined us at the beginning of this meeting, we wrote this book on the particular topic of modeling transitions with different chapters featuring different approaches and applications. In recent years, there have been also several modeling frameworks with this capability to study the dynamics of change towards sustainable future, which can also offer this capability to better understand and contribute to sustainability transition research in general. With this bit of background, I would like to share the first study for today, which is about evaluating the dynamics of pathways towards SDGs at global scales and using systems modeling. This study was originally inspired by some recent international reports and also several scientific studies, all warning that it would be probably unlikely that we achieve all the SDGs together by 2030. And now with different sorts of global disruptions that we are experiencing in different parts of the world, it's even more unlikely than ever. But we all know that failing to achieve global sustainability should not be an option. Therefore, calls have been made for new assessment of the SDGs in light of future uncertainties. Within this context, we wanted to evaluate the long-term dynamics of transitions towards the SDGs across alternative pathways that we can take from today to the future, to the end of century, from the least to the most sustainable future, in terms of diverse societal, economic, and environmental SDGs, represented in 8 goals and 36 specific indicators, and also through multiple time scales, in short term, in medium term, and in long term, to better understand the speed of change over time. A little bit of detail about the methodology. I told you it's a systems modeling study. The model that underpins this study as a simulation engine is called Felix. Felix is a system dynamics model with 11 submodels representing different socioeconomic and also biophysical systems in one integrated framework. It was originally developed at EASA and then later advance in different studies by different people. Using this model, the first step that we took was to quantitatively simulate and produce different pathways from now to the future. We use the story and simulation approach. What it means is basically we used some qualitative narratives of the future, like how the future would look from the shared socioeconomic pathway literature, which is a specific literature mostly related to climate science, but also applicable to sustainability science. We use these 5 different narratives of the future to set up our model. So we had 5 different settings for the model. And then the model took over and reproduced these qualitative narratives in quantitative terms. For each of these 5 narratives, we ran 10,000 model evaluation to explore uncertainties and evaluate possible variations that we can have around these narratives. And then what we produced with model, we compare it against the projection of other studies, other models for cross-validation, as you can see in that plot with multiple subplots on the right-hand side. The second step after producing the pathways quantitatively was to have a lens, to have an indicator to study the dynamics of transition. Obviously, because our study was focused on the SDG, the lens that we were interested in was the SDG progress. So we had a specific methodology to measure this SDG progress as our lens for dynamics of transition. Our methodology looked at the value of 36 indicators and the projected value of these 36 indicators over time by the end of this century, and compare those projected value with a specific science-based quantitative target by 2030, 2050, and 2100. The result of this comparison, the outcome, was a single number, a percentage, with 0 indicating no achievement of the SDGs, but by that time frame, and 100% meaning achievement or even exceeding the target that we had. So with this methodology, what did our result look like? The result that we had maybe 2 major parts. So the first part of our result was more about understanding the dynamics of transitions across different pathways, across different SDGs, and also in different time scales. To give you an example, the result that we had, for example, showed that the simulated dynamics of transition could substantially vary depending on the pathway that we choose, with green recovery, one of our pathways, being the most promising one for a sustainable future and in terms of overall achievements of societal and environmental SDGs. But the story was actually a little bit more complex. Even within the green recovery pathway, the simulated dynamic of transition that we had varied quite substantially between different goals and also in different time scales. For example, societal goals were achieved faster than environmental goals. And in fact, most of the environmental goals remain unachievable by 2030 due to the system inertia for change in short term. But with a longer time frame by 2050 and 2100, and driven by the fact that the system had more time for the effect of pathways to materialize, the initially a slow progress in environmental goal was substantially accelerated over time, indicating that the initial lags could be followed up by positive outcomes in the longer term if we start establishing sustainability pathways from today. The second part of our result was that now that we have an understanding of dynamics of transition across different pathways, goals, and time scales, now how to shift from the business as usual trajectories to the pathways of more sustainable future. So the first one was more about evaluation, and the second one is more about action that we need to take. I guess we are all familiar with the multi-level perspective, and within the MLP framework, this shift from business as usual to a different pathway could be roughly described as some systems change from old regime to new regime, supported by some niche innovations and also external drivers from the landscape. Using the same or similar analytical lens, we quantified the speed and the scale of system change from old to new regimes across systems and over time, in relation to human well-being and capabilities, in relation to sustainable food systems and healthy nutrition, energy transition and universal access, and also sustainable economy decoupled from environmental impacts. And then we try to qualitatively discuss some of the challenges and opportunities that can facilitate these system changes. Those challenges and opportunities are on the ground, things like grassroots support, behavioral change, and also those from the broader landscapes, like major technological trend or socioeconomic change or power shift. The second study that I'd like to share is a slightly different. It has more qualitative nature compared to the first one, and it's about a specific tool called systems archetype that can be used to better understand the reasons for failure. For example, why some of the good transitions like decarbonization, diet shift, equity and justice for all are not happening in some contexts. Maybe we'll start with a little bit of background about this context, problems and failure in general. Problems and barriers in transition research are usually understood by an account of circumstances, for example, by narratives of different events or how events accumulate into patterns over time. I guess there's no doubt that events give us these sound and compelling stories, but they have been also criticized for not giving a proper explanation, given that events are actually the output from the black box of the system, and they do not say much about what's inside the system and how systems work. One can say that events point us to a tip of iceberg, the most visible part of a larger complex, but not necessarily the most important part. System science suggests that for deeper understanding, we need to dig further down to root causes and structures. And they call the unique root causes and structures responsible for recurring problems, recurring issues across case studies as systems archetypes. I would say system archetype is a kind of a niche and not very major part of system science in general, but it's a very useful approach, very useful way of thinking about issues, about systemic problems, and also about planning. So there are like different uses for system archetype in the literature, but one of the specific use for system archetype is their use as a diagnostic tool to identify, as I said, why sometimes some systems fail. And I think this particular use is also useful for transition research to better understand the reason, for example, for resistance or failure in transition. And it's again something I think interesting for the transition community, given that as far as I'm aware of, transitions that we usually report on or narrate are those successful transitions, and we less touch on those that have been unsuccessful in the past. There are 8 different systems archetypes, each representing a certain class of problems, a certain class of systemic issues and barriers. And each of these problems and barriers also have certain structures, certain expected dynamic behavior, and also some specific policy implications to address and to resolve these problems and barriers. For the sake of time, I would like to only focus on one of them for today, eroding ambition. But I guess what I would be saying is applicable to and could be also changed within the context of other archetypes. Eroding ambition is a certain class of problem where low ambition and small goals lead to drifting performance and a slow transition. So what does it mean? To give you an example, imagine the decarbonization context. With more support that we have for energy transitions, with a stronger policy interventions, we have less emission. And that's why you see a link from transition to emission with a negative sign, which basically indicates that with more transition in energy, we have less emission. So the relationship is negative. With less emission that we have from the energy sector, we obviously have less gap from certain emission reduction targets, certain ambitious emission reduction target that we have. For example, the target for 1.5 degree global warming. Again, you see a link here between emission and emission target gap with a positive sign this time, saying that there is a negative relationship between emission and emission target gap. With less emission, we will have shorter gap from the emission target. Yeah, I think I got it right. Yeah. But in reality, there is usually a delay between the intervention that we put in place, for example, for energy transition, and also the impact that those interventions have on the system. Therefore, the emission reduction progress is usually slow, and it takes several decades until we close the emission target gap. And because of this delay, we usually have some negative biases in our ability to achieve ambitious targets in a timely manner, which can also cause increasing pressure from some actor groups, for example, industries that are affected by strong climate policies, to reduce our emission target to something that could be achievable in a shorter period of time. With low ambition target that we obviously have misleadingly a smaller gap from the target, and with misleading sense of achievement with a smaller gap that we have from the target, we have less justifications for support for energy transitions. With less energy transition, we have more emissions, we worsen the emission that we have, and with increased emission, we create further gap from an already reduced target. This chain of causes and consequences can repeat itself over and over again and create a vicious cycle, gradually eroding the important goals that we had. And with that, drifting the performance of the system and also slowing the transition process, as you could see on the plot on the right-hand side. This is just like one way of interpreting eroding ambition in one specific case of transition. There are different ways that the same archetype can be used for interpretation of other issues and barriers. And there are many other ways that other archetypes can be used to explain failures and reasons for resistance. But I guess the point is that once we have a better understanding of the causal roots for issues and for problems, we can therefore better come up with solutions to overcome these barriers and problems. For example, in the case of eroding ambition, and again, in the context of decarbonization, one way to deal with these structural issues would be, for example, we can fix the emission targets, that ambitious targets that we have. For example, we can make them legally binding so they do not change under pressures by different actor groups or by the change of the government. Or maybe another way could be to correct the negative perception around the achievability of target in short term by managing the expectation of stakeholders and also improving our communications about success stories that we had. Therefore, we don't have that pressures to reduce our targets. And I'm sure there are better ways to frame these leverage point to address some of these issues. I think based on what I presented from these two studies, I can now highlight a couple of strengths and limitations, or challenges and opportunities. I'd like to start with the positive sides, the strengths or the opportunities. I think one of the good things with transition models and modeling in general is that they enable systematic experimentation. And systematic experimentation allows us to test and observe the consequences of different theories, different set of assumptions, and different narratives. But why is it important to experiment systematically different theories and assumptions? I guess the simple answer is that it's for having more robust conclusion. It's for having a conclusion which is not biased towards certain set of assumptions that we have, or certain theoretical framework, or certain narratives of a certain transition phenomenon. So that's why we need systematic experimentation in general. We want to test and see the consequences of different ways of framing the problem that we have. And of course, this is something less possible with those more qualitative tools, given their limitation in processing and also tracking of many things, many elements, interactions over time and at the same time. I mentioned earlier that transitions usually emerge in a multi-sector context. They don't happen in isolation. There are lots of connections and interactions with other systems in the environment. I think models, because of their formalized form and also their computational capabilities, can offer us this opportunity for integrated assessment of different systems interactions, the multi-sector dynamics that we have, and also can enable us to better understand some of the complex behaviors that we usually see when transitions interact, things like synergies and trade-offs, for example. Transitions also emerge in a multi-stakeholder context with different views and perspectives about the problem. Modeling can offer new forms for engaging with the stakeholders to co-design transitions and also to co-produce the knowledge. I guess there are different ways that model can help with knowledge co-production in transition research. For example, one particular way would be models as experimentation space. We use model as a simulation engine to test the consequence of different scenarios, different vision, different policies put forward by different stakeholder groups. And once we test and see the result of what different people suggest, we can create a dialogue between different views, different area of expertise, and also we have this shared understanding between different groups of people. And there are already many examples of using model for knowledge co-production in the literature. If you look at, for example, the participatory modeling area. But apart from these strengths or opportunities, there are obviously challenges too. The quantifications by model could be sometimes misunderstood or misused by users. To give you an example, uncertainty is usually a very critical, important part of quantification with models. And if you could look at sustainability science or climate change projections, uncertainty is usually an integral part in their projection. But sometimes this important component is simplified or underrepresented in communications with stakeholders and users, leading to wrong implications. I think here there's a responsibility for scientists and modelers in particular to make sure that the scope of the numbers that they are presented are well understood by the users, and also the uncertainties are also communicated clearly and transparently. Some people argue that models are not good in capturing social interaction on the ground. I guess this is a completely valid argument, but I would say that this might be more valid in more conventional type of modeling, those economic or optimization models that we used to have. New opportunities are emerging in the modeling area for mixing modeling with methods from social sciences for the specific purpose of better understanding and including social interactions on the ground. To give you a few names, transition modeling literature, socio-environmental systems modeling, what else? Yeah, there are probably many other areas of research which are currently looking at integration of social science methods with quantitative tools for the purpose of better incorporating and understanding social factors. And the last thing is that models are usually filled with long equations, complex data structures, and multi-layer spatial data. And some modelers also have this tendency to make their models big and bigger to the point that their models become like a monster, not easily understood even by those who originally developed these structures. This is certainly a problem, but new research directions are suggesting the use of simpler models, and also they encourage more transparency, simplicity, and understandability. And hopefully this could be also a pathway that modeling in the transition community would follow. I've finished my presentation by this last sentence. I think systems modeling, like any other scientific approaches to problems, have and come with challenges and opportunities. It's important that within our community, we acknowledge both strengths and the limitations. And we try to figure out how and where we can make the best use of the strengths, and how and where we can fix the limitations by integrating and complementing modeling with some of the fantastic frameworks and research methods that we currently have in transition community. I leave it here, and thanks.
Thank you, Enayat.